Hello and welcome to this explainer. Today, we're taking a pretty amazing journey upward. We are going to explore the absolute literal limits of human engineering by tracing the spectacular evolution of tall buildings. We'll be starting way back in the ashes of 19th century destruction and climbing all the way up to the modern structural marvels that are literally piercing the clouds today. I'm honestly so thrilled to guide you through this, breaking down exactly how engineers and architects managed to build so incredibly high.
Right off the bat, I want to hook you with this staggering number, 678.9. That is the height, in meters, of Merdeka 118. It's the world's second tallest building, located right in Kuala Lumpur, Malaysia. Just process that scale for a second. It is second only to the Burj Khalifa. We are talking about a structure that rises over 2,200 feet into the sky. It's massive, but it really begs the question, how did humanity get to a point where constructing a 678-meter megatall skyscraper was even physically possible?
Okay, let's dive into this. Because to truly understand our modern skyline, we actually have to rewind to a pivotal moment of absolute devastation. The story of reaching the clouds, quite literally, begins down in the ashes of the 19th century.
The 1871 Chicago fire was a profound, catastrophic tragedy that devastated the city. But in the wake of all that destruction, it birthed a completely unprecedented opportunity. The cleared land, combined with the urgent need to rebuild, basically forced engineers and architects to completely rethink urban construction. They started pushing the very limits of newly available engineered building materials, and they began conceiving vertical transportation systems. So, in a weird way, this tragedy was the ultimate catalyst for the invention of the skyscraper.
And from there, over just a few decades, human ingenuity took an insane leap. In 1885, Chicago saw the completion of the home insurance building. By utilizing cast iron, which, yes, was a bit brittle, but it had high compressive strength and allowed for rapid on-site assembly, it reached 55 meters, or about 12 stories. That's widely considered the first skyscraper. Fast forward a bit to the late 1920s and 30s, and suddenly identity, coupled with some massive architectural egos, fueled this frantic building boom. By 1931, the Empire State Building in New York just completely shattered expectations, rising to 382 meters. And what's truly mind-blowing here, it was planned and constructed in just 1 year and 45 days, using over 50,000 metric tons of steel. No way, right? But here's the thing. Building high isn't just about stacking materials on top of each other. Every tall building is in a constant wrestling match with what I like to call invisible opponents. You've got the massive vertical loads of gravity, you have intense aerodynamic lateral forces from wind, and of course, the totally unpredictable shear forces of seismic activity. For a building to survive, it has to organically absorb and manage all of these forces simultaneously.
So, the crucial point is that engineering isn't just rigid math or rote optimization. As Mark Sarkeesian, a world-renowned leader in skyscraper design, beautifully puts it, it requires an intuitive understanding of the interrelationship between forces at play. You literally have to look at a site's geology, the wind patterns, the seismicity, and devise a system where the building works with nature rather than just stubbornly fighting against it.
And that brings us to a really beautiful concept: structure as architecture. True efficiency in these megastructures happens when the structural solution, the very bones keeping the building standing against those invisible opponents, and the architectural beauty are the exact same thing. We aren't just hiding steel frames behind decorative walls anymore. The structural necessity becomes the visual identity of the tower.
And this brilliantly illustrates that shift. We've evolved from the rigid, highly functional early iron frame structures of the 1880s straight into these towering, complex, modern megastructures. It's a huge leap from simple load-bearing frames to incredibly sophisticated systems combining steel and concrete that allow buildings to gracefully slice right through the wind and absorb the shocks of the earth.
Now let's move back to our ultimate case study by throwing another massive number into the mix: 89. That is the staggering number of elevators required just to make Merdeka 118 functional. Think about it. When you're moving people up and down a 118-story vertical city, the logistical nightmare is very real. The amount of non-rentable space that has to be dedicated entirely to vertical transportation, mechanical layers, and maintenance is absolutely astronomical.
When you really break down the anatomy of Merdeka 118, the top floor actually sits at 502.8 meters and the roof caps at 518.2 meters. But here's the kicker. The spire alone is 160.7 meters tall. That's the equivalent of a 40-story building, just acting as a spire. And that massive addition is precisely what pushes the architectural height of the building up to 678.9 meters, officially securing its prestigious ranking on the global stage as the tallest building in Southeast Asia and second in the world.
Now, what's really interesting here is the architectural DNA. It's deeply rooted in human history. The diamond-shaped glass facades are meant to signify the diversity of Malaysians. But even more fascinating, the very silhouette of the tower was designed to mimic the outstretched hand gesture of Tunku Abdul Rahman as he passionately chanted Merdeka, which means independence, 7 times back in 1957. Plus, to ensure it stands out day and night, the whole thing is wrapped in 8.4 kilometers of LED light strips. It's essentially a building that physically embodies a very specific historical moment.
Of course, an undertaking of this magnitude doesn't happen without debate, specifically regarding its Rm5 billion cost. Now, from the government's perspective, this was definitely not a waste, but a major driver that would generate immense economic opportunities and elevate the capital's attractiveness globally. Conversely, there was substantial public criticism arguing that this Rm5 billion was essentially public money, funded through a state-owned enterprise, and it would have been way better spent on basic infrastructure and raising the minimum wage. It's a prime example of the intense cultural and economic debates that these megatall structures inevitably spark.
And beyond the economics, structures of this immense scale naturally draw extreme human interaction. On one hand, you have official events like the Sky Race, this massive tower running event where 5,800 participants push their physical endurance by climbing 2,845 steps all the way up to level 118. But then on the flip side, the building has also drawn highly dangerous illegal stunts. International rooftoppers from the US and Russia actually went viral for illegally scaling the tower and its spire, prompting serious security investigations and trespassing charges. These megastructures just act as literal magnets for both incredible athletic endurance and, well, reckless thrill-seeking.
As we wrap up this explainer, I want to leave you looking forward. Consider this. In the last 200 years, the global population grew from 1 billion to nearly 7 billion. And in less than 4 decades, we are going to hit 9 billion. The way we traditionally build outward, consuming vast amounts of land and energy, it simply cannot be sustained. So looking at this incredible engineering journey from the 1885 home insurance building all the way to the breathtaking heights of Merdeka 118, I have to ask you, our compact, dense, humanistic vertical cities are absolutely crucial, only sustainable future? Something to think about. Thank you so much for exploring the sky with me today. Keep asking questions, and I'll see you in the next explainer.